In this video lecture, we're going to start talking about the basic structure of any class in Java. Okay, let's get started. So what exactly is in a class? For starters, recognize that a class is the basic atomic unit of structure in Java. The basic rule is one class is contained in one .java file, and the class name and its file name must match exactly. So for example, the class named myClass must be contained within the file myclass.java. This isn't just a good practice, it's required by the language and enforced by the compiler. As we said before, classes bundle together two things into one place: data and operations, or in Java terms, instance variables and methods. Taken together, these two things are the members of the class. Class names are Java identifiers, or names that we as users get to specify. As we've already seen, these identifier names must observe certain rules, such as characters and numbers only, they can't start with a number, and so forth. Beyond this, they should adhere to good naming conventions, and they should be descriptive and meaningful. But more specifically, classes represent real-world things, and as such should be noun-based names. By very well-established Java convention, class names should always begin with a capital letter and use camel case naming thereafter. By contrast, object names are specific instances of classes and are akin to regular variables. Again, by very well-established Java convention, object names should always begin with a lowercase letter with camel case naming thereafter. As we'll see very clearly as we move ahead, these conventions help us to differentiate classes from objects. So for example, as we see here, person is a class and begins with a capital letter, but Joe Smith is an object or a specific instance of a person and therefore begins with a lowercase letter. The same things apply here. Cat with a capital C is a class, but Fluffy is a specific instance of a cat. School with a capital S is a generic school, but Sierra College with a lowercase s is a specific instance of a school. You might notice in these three examples that Joe Smith, Fluffy, and Sierra College would normally be considered proper nouns and as such would have leading capital letters. However, in programming, the fact that these are objects trumps that these are proper nouns, and all of these begin with lowercase letters. That's kind of hard for a lot of new programmers to get used to, but it's a very well-established convention and we'll get used to it. Let's focus our attention now on the fields or instance variables of a class. These are just the set of variables which collectively describe some class. These can be of any of the 8 primitive data types in Java or even of other class types themselves. Every specific object that we create from a general class blueprint will have its own values for each of these instance variables. One important point is that all of the instance variables of a class should be declared as private for reasons that we'll discuss shortly. So all of the instance variables taken together fully describe the state of any object at some point in time. For example, let's say we have some class named student, and we'll imagine that a student can be fully described by his or her name, birth date, student ID, GPA, and number of units completed. These are the instance variables of the student class, and they are of the data types indicated here. Every instance variable has an associated data type. Notice that these last three are primitive data types, whereas these first two are of type string and CS12 date, which means we have some classes nested within the student class. Now let's say we have a specific instance of a student, an object named Joe Jones. The values of the instance variables for this particular object are Joe Jones for the name, 7/18/1995 for the birth date, this long number for the ID, 3.65 for the GPA, and 46 for the units completed. There is a one-to-one mapping of the specific to the general. Now let's turn our attention to the methods of the class. Methods are how a class interacts with the outside world. They specify both what a class can do and what can be done to a class. To find the list of available methods for any class, we would consult its API. Many of the methods of any class are public, which means that outside client applications can call them. But some of the methods may be private, which means they are only for internal use, and we would not find these in an API. Things we might use the methods of a class for would be to initialize, get, or set instance variables. We might call other methods to perform calculations or display the state of an object, or perhaps exchange data with some outside objects. There are several general types of methods, but we'll focus our attention on these first two types, constructors and accessors and mutators. Although this order isn't set in stone, this diagram shows the basic conceptual organization of many Java classes. Typically, we'll find the instance variables toward the head of the file and the constructors as the first group of methods. To use a class, we don't really care about this internal layout, but when we start writing our own classes, this is the general layout we'll use. Note that as a broad generalization, a class consists of a handful of data, shown here in red, and a lengthier group of methods which operate upon that data, shown here in blue. Next, let's turn our attention to the constructors of a class. Constructors in Java are simply special methods which have exactly the same name as the class itself. We use them in programs to instantiate or create new objects of that class type. Constructors initialize the data of a new object and perform any needed startup actions. It's possible, and actually quite common, to have multiple different versions of a constructor with the same method name. These just represent alternate ways of creating new objects, as we'll see on the next slide. Each different method, though, must be distinct somehow in terms of number of input arguments, their data types, and the order of the inputs. The actual names of the input arguments are ignored in making these distinctions. Having multiple different constructors of the same name is an object-oriented concept called overloading. Here are several examples of constructor types and overloading. A default constructor takes no input arguments. You might use such a constructor when you want to create a quick and dirty object and rely upon the designer-specified sensible default values. For example, here's the default constructor for CS12date. It accepts no inputs here inside the parentheses and simply defaults to the current date. Quick and easy. By contrast, a full constructor gives the application programmer full control over creating new objects by allowing them to specify values for all of the instance variables. For example, here's the full constructor for CS12date. It allows us to explicitly specify the month, the day, and the year. And below, here are some other constructor forms provided by CS12date. For example, we could create a new CS12date by specifying just a month and a day, or just a year, and the remaining values would be set for us. All of these constructor forms taken together illustrate the idea of overloading, which simply means providing different alternate ways of setting up a new CS12date object. Notice that all four of these constructors are distinct and unambiguous. No inputs here, 3 int inputs here, 2 int inputs here, and 1 int input here. 4 different ways of creating a new CS12date object depending upon how easy or specific you want to be.